session we will concentrate on numericals on Thevenin's and Norton's theorem. So in the earlier session you might have studied the concepts of Thevenin and Norton's theorem. So in this session we will concentrate on numericals. So let us see the first problem. So in this it is asked us find the current through 2 ohm using Thevenin's theorem. So it's a simple question. So the current through this 2 ohm I need to find using the Thevenin's theorem. So that means according to the Thevenin's theorem we need to convert this network across A and B into an equivalent practical voltage source. So to find out the practical voltage source, remove the load. So that means the network becomes something like this. So B and this is the A, this is the 5 ohm, this is the 4 ohm, this is the 20 ohm, and this is the voltage source plus minus 50 volt. So I need to find the voltage drop across this AB. So voltage drop across AB can be found using the tracing a path in this direction. So for that I need to find a current. So I will assume a current I in this loop. Here it is connected to open circuit, so no current flows through this. So I is equal to 50 by 25. 20 plus 5, 25, 50 by 25, that is equal to 2 amps. Now V0, Thevenin's equivalent voltage V0, if I consider B as a lower potential and A as an upper potential. So to find out a V0 across A and B, I need to trace a path from lower potential to upper potential, and sum of the voltage drop in that path is equal to V0. So V0 is equal to trace the path. So 20 into I. Current is flowing in the opposite direction. Path direction and current direction, if it is opposite, plus 20 into I. Here no current flows, so voltage drop across the 4 ohm is 0. So V0 is equal to 20 I, that is 20 into 2, that means 40 volt. So Thevenin's equivalent voltage is 40 volt. Now to find the resistance, to find R0. So how to find out the R0? So equivalent resistance across open terminal A and B when sources are made to 0. So if I make the sources to 0, so voltage source is made 0 by short circuit, and the resultant network becomes something like this. B and A, 4 ohms, 5 ohms and 20 ohms. So what is the equivalent resistance across this path, this terminal A and B? R0 equal to 4 in series with means plus 5 parallel 20. So that means 4 plus 5 into 20 divided by 5 plus 20. So this is 4 plus 4 means 8 ohms. So R0 is 8 ohms, V0 is 40 volts. So what happens? The entire network becomes. So the network becomes V0 in series with R naught, this is the B and this is the terminal A, and which is connected across the resistance 2 ohm. So this is R naught, which is 8 ohm as we have calculated, and this is B is the lower potential, A is the upper potential. Here what we considered, B is the lower potential, A is the upper potential. So this is minus, this is plus 40 volt. Now what is the current through 2 ohms? So current through 2 ohms equal to 40 divided by 10, that is 4 amps. So like this, whenever it is asked to find a parameter using Thevenin, so we need to convert the rest of the network into Thevenin's equivalent voltage source. Then by adding the resistance, we need to find the current. Find the Norton equivalent circuit across A and B. So across this A and B, I need to find Norton equivalent circuit. Norton equivalent circuit means replacing the circuit across A and B by an equivalent current source. So the value of the current is obtained by shorting the terminal A and B. So if I short this terminal, so what will happen? Now here only I will make, if I short this, so now this 60 ohm is in parallel with short circuit. So whenever a resistance is in parallel with short circuit, this effect is 0. So the network becomes something like this. (40 ohm), current of 5 amps. This is 5 ohms. Sorry, this is the 1.5 amps, not a 5 amps, 1.5 amps. This is the 25 ohms. This is plus minus 30 volt. This is 20 ohm. Now here this current is I naught, short circuit current, Norton equivalent current I naught, which is flowing from A to B. Now to find out this current, either I need to apply mesh current analysis or node voltage analysis. Now I will consider this is the one node, this is the another node, this is the another node, and this is the reference. So if I find the voltage across this point, voltage at this node, then I can find out I naught easily. So if I find the voltage at this node, we can find I naught by this voltage minus 0 divided by 20. Now I will consider this one as V1. This is the V2 and this is the V3. Now here a ideal voltage source is connected between these two. So this V3 becomes a 30 volt. Because V3 higher potential side minus lower potential side equal to this 30 volt. So V3 equal to 30 volt. Now if I find V1, then it is easy for me to find the I naught. So I will apply KCL to node V1. So what happens to KCL to node V1 when I apply? Current is into the node, so 1.5 Okay, this I will consider as outgoing node because the direction is, I am not considering this. This is the outgoing current. So minus V1 by 20. This is the outgoing current, V1 minus 0 by 20. What this current, outgoing current, minus V1 minus 30 divided by 40 equal to 0. So if I take variables to the other side, what will happen? V1 by 20 plus V1 minus 30 by 40 equal to 1.5. So if I take a LCM and then if I take cross multiply, then 2V1 plus V1 minus 30 equal to 1.5 into 40. So 3V1 equal to 60 plus 30, that is equal to 90. So V1 equal to 30 volt. When V1 is equal to 30 volt, what is I naught is? I naught, Norton current I naught equal to V1 by 20. Because V1 minus 0 divided by 20. So V1 by 20. So that is 30 by 20 equal to 1.5 amps. So I naught is equal to Norton equivalent current equal to 1.5 amps. Now to find R naught. To find R naught, what we need to do? We need to find equivalent resistance across A and B when sources are equal to 0. Sources means 0. So the network becomes B, E. This is the 40 ohm, this is the 60 ohm, this is the 20 ohm, this is 25, and this is 5 ohms. Now in this case, if you observe, this 25 plus 5, 30 ohm is in parallel with short circuit. So whenever any resistance in parallel with the short circuit, its effect becomes 0. So now what is the resistance across A and B? It is something like 40 and 20, which is in series, is in parallel with 60 ohm. So R naught 60 parallel 40 plus 20. So that is 60 into 60 divided by 60 plus 60 equal to 30 ohm. So R naught is equal to 30 ohms. I naught is equal to 1.5 amps. So this I naught is flowing from A to B in the load. So Norton's equivalent circuit becomes a current source in parallel with resistance B, A. So in the load, the current should flow from A to B. So it is the upward direction. And this is 1.5 amps and this is 30 ohm. So this is the Norton's equivalent circuit across A and B. Let us concentrate on next problem. find the Thevenin's equivalent circuit across A and B. Now Thevenin's across A and B. So I need to find potential. Thevenin's equivalent circuit means it is the converting the network into equivalent practical voltage source. That means ideal voltage source in series with the resistance. Now to find out the potential across A and B, if I can calculate VA, potential at A and potential at B, then I can find out potential across A and B. Correct? VA minus VB or VB minus VA based on the values. So I need to find potential at A as well as potential at B. So here I will apply node voltage analysis. So this I will take it as VA, this as VC, this as VB. So this node is same as node A, this node is same as node B. Now if I apply KCL to node VA, okay, now this is the one more which is a ground. So apply KCL to node VA. So what will happen? So only two elements are connected. So both the elements current I will consider as outgoing current because I am writing the equation for VA and I will assume VA is higher than other voltages. So minus VA minus 30 divided by 10. So this is the current flowing through this. So this is 0 and this is 30 volt. So current flowing through this branch is VA minus 30 by 10. It is the outgoing with respect to VA, so minus sign. So current through this branch next. So minus VA minus VC by 10 equal to 0. So what will happen, taking to the both on with respect to variable, so multiplying with the minus sign, so it become plus. So LCM is same, so cross multiplying it is 0, equation becomes 2VA minus VC equal to 30. So this is the equation 1. Now second equation, writing the KCL to node VB. So what will happen? Minus VB by 10. That is the current flowing through this 10 ohm. VB by VB minus 0 by 10. That is outgoing current minus VB. Now, what is this point? What is the current flowing through this branch? Okay, I will consider this. So minus VB minus VC by 20 minus VB and VB minus VC by 20. Now what is the current flowing through this branch? So this is VB. So what is the potential at this point? Because current flowing through passive elements depends on potential drop across its elements. So it is, this voltage is VB minus 20. So this is VB minus 20. Potential at this point is VB minus 20. So VB minus 20 minus VC by 20. So it is minus VB minus 20 minus VC whole divided by 20 equal to 0. So here no ideal current source. So everything is with respect to passive elements only. So multiply with minus 1. By multiplying with the minus 1, it becomes a plus. So 20, 20, so take a LCM of 20 and then cross multiply with 0. So the equation becomes 2VB plus VB minus VC plus VB minus VC minus 20 equal to 0. So 2VB, 4VB minus 2VC equal to 20. So this is the equation 2. Now by applying KCL to node VC, what will happen? Minus VC minus VA by 10. This is the current flowing through this branch. Then current flowing through this 10 ohm is minus VC by 10. Then current flowing through this, it is minus VC minus VB by 20 minus, what is the current flowing through this? VC minus this. So VC minus VB minus 20 divided by 20. Then this current 5 amps is incoming to the node. So plus 5 equal to 0. Right? So what happens this 20 if I take a LCM? Okay, take this to other side, or 20 taking a LCM and taking to the other side, that's also fine. So if I rewrite this, it is okay, I'll take this other side and then I'll take a LCM of 20. So it is VC minus VA into 2 by taking LCM plus 2VC plus VC minus VB plus VC minus VB plus 20 equal to 100. 5 into 20. So it is minus VA minus 2VB plus 6VC 2 plus 2 plus, okay, minus 2VA minus 2VA minus 2VB plus 6VC equal to 80 is the equation 3. This is the equation 3. If I solve these 3 equations, I will get VA equal to 30 volt and VB equal to 20 volt. So I am not interested in VC, so I am calculating only VA and VB. So VA equal to 30 volt, VB equal to 20 volt. Now what happens to this V naught? V naught is equal to VA minus VB equal to 10 volt. That means by considering A is a higher potential, B is a lower potential, I am finding the Thevenin's equivalent voltage across this A and B. Now, next what? We need to find R naught. Now R naught is calculated by shorting and opening the current sources and voltage sources. Now if I do so what will happen? There is no series or parallel combination. It is something like star delta network will come. So in this case, instead of directly finding the R naught, I will find out I naught and then we will calculate R naught. So to find out I naught, that is the Norton equivalent current. So short circuit current across A and B. So I will short this terminal A and B. A and B. Now what will happen? Now when I'll consider as a VA, VC and VB. Now if I compare the equation with this and this, VC equation, node equation at C remains the same. Node equation at C remains the same. So it is the same as this equation. That is minus 2VA minus 2VB plus 6VC equal to 8. Okay. Now with respect to VB, so this VA is higher potential I have considered. So this is now I naught. Norton equivalent current I naught. Now what happens to the node equation at VA? To this equation, an outgoing current is added. Outgoing current. Correct? This is the outgoing current. So in this equation, node equation is this one, minus VA minus 30 by 10, this term, and minus VA minus VC by 10, along with this minus I naught equal to 0. So taking to the other side, so the equation is 2VA minus VC plus I naught equal to 30. Now equation 1, equation 2. Now similarly, if I write the equation for this B, so all the terms will remain same, but here the current of I naught is into the network. So in this equation, 4VB minus 2VC minus I naught equal to 20. So you can try this. You can apply KCL to these three nodes and you will get these three equations. Now the three equations but four unknowns. Now how to reduce it into three unknowns? Now whenever I short this, what it means? This VA and VB are equal. Potential at these 2 points are equal. So if I substitute VA equal to VB in this set of equation, so what I will get? Minus 4VA plus 6VC equal to 80. This is the first equation. And here minus 2VA minus VC plus I naught equal to 30. Then 4VA minus 2VC minus I naught equal to 20. Now three equations and three unknowns. Three equations and three unknowns. And if you solve for this, you will find I naught equal to, you will find I naught equal, you will get I naught equal to 1 amps. So now V naught is equal to 10 volt, I naught is equal to 10 amps, 1 amps. So R naught equal to V naught by I naught, that is equal to 10 ohms. So Thevenin's equivalent circuit becomes Thevenin's equivalent circuit becomes B A is a higher potential plus minus 10 volt 10 ohms. So this is the Thevenin's equivalent circuit. So now see here in this particular case, to find out the R naught, instead of the direct method, we have followed R naught is equal to V naught by I naught, Thevenin's equivalent voltage by Norton's equivalent current. This is also can be adopted to find out R naught. Okay. Find the current through R using Norton's theorem when R equal to 667 ohms. So when this R is equal to 667 ohms, you need to find out current through this R using Norton's theorem. So to find the I naught, Norton equivalent current, I will redraw the circuit. And this, in place of the load, you need to short it, and I take it as I naught. This is the X, this is the Y. This is the 1000 ohms, 6000 ohms, plus minus 12 volt, and here it is plus minus 2000 IA, where the current through 1000 ohm is IA. Okay. Now I naught I need to find out. So I will apply mesh current concept. I1, I2. So what is IA is now? IA is equal to I1 minus I2, because I1 is in this direction, I2 is opposite. So IA is equal to I2. So by applying KVL to this mesh, what happens the equation? 12 minus 6000 I1 minus 2000 IA minus 1000 I1 minus I2 equal to 0. So by applying KVL to this, so what you will get? 12 minus 6000 I1, IA is equal to I1 minus I2, so minus 2000 I1 minus I2 minus 1000 I1 minus I2 equal to 0. By taking this to the other side and by simplification, I will get 9000 I1 minus 3000 I2 equal to 12. This is the equation 1. 9000 I1 minus 3000 I2 equal to 12. Now applying KVL to this mesh. So what I will get? 1000 into I2 minus I1 equal to 0. So or I2 equal to I1. If I substitute I2 is equal to I1 in this equation, as I0 is equal to I2, I0 is equal to I2, so I will calculate I2. So 6000 I2, by substituting I2 is equal to I1 or I1 equal to I2 equal to 12. So I2 is 2 milliamps. I2 is 2 milliamps. Now to find R0. R0 is calculated. Can we find directly R0 here? No. We cannot find R0 directly. Why? The reason is here dependent voltage sources present in the network. So in such a case, to find out R0, we need to find V0. So what will happen up? How to find out a V0? Open circuit X and Y. So this is 1000 ohm, 6000 ohm plus minus 2000 IA, where this is IA and this is the plus minus 12 volt. Now this current is the same. Current IA is flowing in this mesh. If I consider like that, so it is applying KVL to this. My 12 minus 6000 IA minus 2000 IA minus 1000 IA equal to 0. So 9000 IA equal to 12. So IA is equal to 12 by 9000, that is equal to 1.33 milliamps. 1.33 milliamps. So now what happens to this V0? This is the potential drop across this lower potential, higher potential. So V0 is equal to 1000 IA. That is equal to 1000 into 1.33 milliamps. So it is equal to 1.33 ohms. No, sorry, 1.33 volts. So now what happens this R0 is? R0 is V0 by I0. So here I2, so I0 is equal to same as I2 equal to 2 milliamps. So it is 1.33 divided by 2 milliamps equal to 667 ohm. 667 ohms. So this Norton equivalent circuit becomes this is 2 milliamps, this is 667 ohms. Now current through R equal to 2 milliamps into 667 resistance of the other branch divided by 667 plus R, current through R. So find the current through R in the question. Find the current through R using Norton's theorem when R equal to 667. So when R equal to 667, what happens? 2 milliamps into 667 divided by 667 plus 667. So it is equal to 1 milliamps. So it is 1 milliamps. Thank you.